Hi guys, welcome to our channel of Patract Labs. This is the first episode of our tutorial series. In our tutorial series, we will be teaching you how to write smart contracts, testing them, and deploy them using the tools, languages, testing environments we have in Patract Labs. Hopefully, after this tutorial, you're getting very familiar with how to use smart contracts, write them, and deployment using the tools we have. Trust me, it will make your life much easier by using all the tools we provide for you. So before we getting started to today's topic, let me briefly introduce who we are. We are Patract Labs. We're providing the most popular and easy to use tools for writing smart contracts on Substrate using Wasm. So you might be asking, what is Wasm and what is Substrate? Wasm is short for WebAssembly. It is the future of smart contract because it is lightweighted, it is performant, it has all the great features you don't get from EVM. And Substrate is the next generation blockchain, allows you to build customized blockchain by adding modular components. So by writing some new modular components, you can get a brand new chain easily. So this episode will be focusing on our newly invented Wasm programming language called Ask. So this is our website. You can get all the information of our newly published products, our complete documents, and all the new changes happened on Substrate and Polkadot. So let me get started into today's topic, which is Ask tutorial. What is Ask? Ask is an embedded domain-specific language to write WebAssembly smart contract on Substrate using TypeScript. Ask is not a standalone language like Solidity, but like a superset of assembly script, or we call it like a contract format. By just using customized decorators, it tells the compiler how this smart contract is defined, and then the compiler will further compile them to Wasm bytecode compatible with Substrate palette contract. As we all know, we already have a language called Ink. It allows you to write smart contract in Wasm smart contract in Rust. So why we're having a new language called Ask? It has many reasons, but I believe the following 5 reasons are most important. First of all, Ask is just a variant of TypeScript. It is very easy to compile to WebAssembly without learning a new language. I believe many developers are from the front-end world, and for them, writing Ask is as easy as writing front-end code. It has no learning barriers, no learning curve. I believe it's much easy for other developers to get into the Wasm smart contract world. Assembly script is the most popular language for Wasm besides C, CPP, and Rust. So it has great community support and all the tools other people have already built for assembly script. Assembly script targets WebAssembly feature set specifically, so giving the developers very low-level control over their code. Assembly script is just designed for WebAssembly. You can see that from its name. Most importantly, WebAssembly script integrates with the existing JS ecosystem. There's no heavy toolchain to set up. Unlike Ink in Rust, you have to set up cargo contract. It's very time consuming. For Ask, you don't have to do them. You just simply use npm to install it. Number 5. The Wasm code compiled by Ask is very small in size and has good contract execution performance when you are comparing it to Rust, which is Ink, right? So let's get into the first project in Ask, because I believe writing a project, gets your hands dirty is the most efficient way to learn a new language. And set up Ask is very easy. So let's get into the world of code. Let's first create a new directory. So in this directory, I already create this directory called Flipper. Let me remove it so we have a clean start. First, just make a new directory, make the Flipper, cd Flipper, and then you just install Ask. We have a CLI tool called PL Ask CLI. You just install it. You just use it. It supports npx, so you can use it to initialize a new project. It's gonna take some time to set up, but it's because it's npm. All right. So you can see this directory has been set up. This is no modules. This is package log.json, and this is the directory we're gonna write contracts in. It's called contracts. So first, just create a new file so that okay. So let's start writing the simplest contract called Flipper. It is gonna be the contract tells you the basics of how Ask works, the grammar, and the basics of palette contract and the mechanism. So first let's create a contract decorator with class called Flipper. So once we have this class, let's declare a class property called flag. This is gonna be a type boolean. Then let's have a constructor method. It's gonna be empty for now because for the contract constructor we use our own decorator. So let's create a constructor decorator, and we call it default. It's gonna be the method to instantiate the contract. Init flag boolean returns void. So keep in mind that the constructor method has to return void as the return type. But for the input, you can have as many as input parameters you want, as long as they are following the scale codecs. For information of scale codecs, you can check the check substrate for details. So we said this dot flag equals init flag. And so once we have a constructor, we need some public methods. A public method is a method that is exposed to the outside world. So other users can use RPC to call them. Message, let's call it message, and then flip. It takes no input parameters, and then void as the return type. Const v equals this dot flag. This dot flag equals v. So this is basically revert the value of v, a flag. So if it's true, then revert it to false. If it's false, change it to true. Let's have another message. Message means it's a public method of substrate of the blockchain. And for this, let's have mutates equals false. Get boolean as return type, return this dot flag. So this is the simplest contract we're gonna have. First we set the flag, we declare the storage, we call it state as a boolean, then we initialize it with the value we want to initialize with, then we flip the value, basically revert the value, then basically we mute, sorry, not revert, we muted the value, and then we have a get function to get the current value of flag. Okay, so this is super simple. Let's compile it. To compile it, it is super easy. Just run npx pl ask cli compile contracts flipper.ts. Oh, you see, so we misspell it, and the compile hints us with the correct one. Let's replace it with constructor and compile it again. So you can see the ask compile is very smart, detecting the errors you have in your code. You say, do you mean mutate? I have a grammar error again. It's called not mutate, it's not mutate. Great. Now you can see it has been compiled correctly. The Wasm is the Wasm bytecode that is going to be deployed to the blockchain. And the metadata define the public method and the storage of your contract. It tells the blockchain how to operate them, how to store the data. So let's get into the decorators we have here. The first decorator we're going to see is called @contract. It marks this class as a contract and then defines the entry point for the compiler. So as long as you have one @contract in your code, the compiler knows how to compile them from this entry point. The second one is the constructor. This is the method decorator for contract instantiation. With this method, it tells the blockchain how to instantiate this contract, such as setting the initial values, setting up the storage, stuff like that. And the message decorator, it marks this method to be exposed to the blockchain. So as a user on the blockchain, I can use RPC calls to call this function and therefore to interact with this blockchain. So if you see the message and mutate equals false, that means this is the method that will not change the blockchain state. So you see this flip method, it basically changed the value of the flag. So internally, when you call this method, the blockchain will change the value you stored in the database and sync them. And for this one, you have mutate equals false. And for this one, you need a transaction, or in Substrate, you need an extrinsic to make this happen. And for this message mutates false, it is normal RPC call. It doesn't require any blockchain transaction to make it happen. So no new values will be written or delete, or any value get changed or deleted from the blockchain database. And so let's look at the metadata.json. This is the file generated by the compiler. First, you can see it tells you which metadata version we are using, the language version, the compiler version, and the name of your contract. Further, we have a decorator. A decorator has name init flag. It has a parameter called init flag. It is a type boolean and has a selector. The selector is a Blake2B hash of your contract method. It is called Blake2B. It basically hashes your method name and generates the selector. So when using RPC calls, you call the RPC with the select name and the values you want to have. And it has messages. It's called a flip. You can see it's mutate equals true, means it's gonna change the database state. It requires a new transaction to make it happen. And the payable means if this message carries value. So we're not using this for now. And return type null. So basically, the metadata tells the blockchain how to handle the input and return data. The second one is get, and the mutate is false, means it requires no blockchain transaction, and we're not change the blockchain database. You can see events is empty right now, so we're gonna add some events to make it happen. And for the storage, We only have one storage for now. It is called flag, and it has a key. The key is this is stored in the KV database. Remember, the blockchain database is just a KV database with key value map. So this defines the key of your contract, like how the flag will be marked as this key and store that in the data in the blockchain database. So let's make some changes to this contract so we understand how event works. So when a user is interacting with the contract, usually you want to expose that information to the outside world. So the outside world knows what happens to the blockchain. Otherwise, the blockchain is just like a black box. Even you change the contract, no one knows what happens. It is very suspicious. So we don't want that to happen. So usually when you change a value in your contract, you especially like those DeFi applications, you want to expose the world what happens with your contract, what kind of assets people are trading. So sending events out of the changes in your contract is very important. To do so, let's introduce the event decorator. It is very similar to the contract. You put the decorator on the class. Let's call it class flip extends event. So before we're doing that, you might be noticing where this event coming from. So to do so, we need to import those things. We need to what things we're gonna need is gonna be account ID. Account ID is just a system parameter type that you use to communicate with the blockchain, or specifically pad a contract. Then message is a global variable. We'll be covering that later. Event, you import them from Ask LAN. So once you have imported them, you define this class. You have from account ID. Remember, account ID is just a type. It's a contract parameter type. Flip result. You want to tell the outside world what kind of result you have after you flip this, right? The type is bool. As other classes, you need a constructor for this. Constructor from account ID flip result. We call super because we inherit this from another class. We call the event. Then we set this dot from equals from this dot flip result equals flip result. Simple, right? And then once you have defined this event class, you need somewhere to emit them. So the place we're gonna emit them, we have it. So when you do a flip, you want to tell the outside world, oh, where I have flipped this, right? So to do so, you create a new, instantiate a new flip class with msg.sender. Remember, msg is the environment variable that carries the contract information. This flag. This flag is just this one here. Then you have to emit. So this basically instantiate a new flip class with the information here. Then you emit it, so the outside world knows what happens. Okay, let's compile it again. All right, it's done. Let's see what changes we are getting from metadata. So since we didn't change the constructor and the other messages, also most of them are going to stay the same, but we have a new section called events. We have the event name called flip, and then the first one is from. Index is false, so we're going to talk about this index later. And then flip result, boolean, and type. The type is just the internal type used by the blockchain. Okay, so it all goes well. Let's look at what happens. So in here we have msg.sender. So message.sender tells the blockchain who is using this method. So when you are sending RPC call for flip, the blockchain knows who is the sender, so it passes the value into this method. This MSG is available across the entire contract. You can get other information such as blockchain, blockchain number, blockchain timestamp. So you can implement, like time log, other stuff like that by using the environmental variables. So, but we notice this index is false. So what is indexed? So let's add something to this flip class. Let's have topic. And then compile it again. So we add our topic on from. All right. So it all goes well. Let's look at the metadata, what things we have changed. In the first one of event, flip, you can see the arc is the first act of event, flip events. It says index true. So when index is true, you can it tells the third party apps such as D apps, this is the information to be indexed. It allows the apps to index certain values. For example, Etherscan uses add topic decorator, uses topic to track back traits. For example, in the database, in the third-party databases, you can index this value, such as like DeFi, you have who sending fund to who and to whom, and then you get the detailed trade information. And so index is true is set here once you introduce topic. You put the topic in the property of flip, class flip. So this is today's video. This is today's sharing. We will be covering more stuff such as writing a ERC20 contract, getting into more depths of how Ask is working under the hood in the next episode. So stay tuned.